Okay guys, now let's derive period of SHM, that is T is equal to 2 pi over omega. Alright, to begin with, we already have seen that X, that is displacement in SHM, is equal to A sine omega t plus phi. Now just to understand whether this is what is the time period, let us substitute instead of t, let us substitute t plus 2 pi by omega. Alright, so okay, we did that. So when we take LCM, we find that this becomes omega t, this becomes omega t plus 2 pi, the whole over omega. That omega gets cancelled. So what we end up with is omega t plus 2 pi plus phi. Now I've just written it in form of allied angle format, 2 pi plus omega t plus phi. Now we know that 2 pi, whenever 2 pi plus is there, that means it's returning back to this itself. Alright, now we need to understand a bit of coterminal angle formula. Now coterminal angle formula says what? Theta plus or minus 360 n, that is number of times, is equal to theta. Now let's understand. Now see, when we start from here, it is 0 degree and sine 0 is 0 and cos 0 is 1. We know this is cos, this is sine. Alright, so what do is we move around by 2 pi, that is 360 degree. We come back again here. Alright, again sine 2 pi is 0 and cos 2 pi is 1. Then again we move around here by another 360 degree, that is now we have moved around by 720 degrees. Again we get the same value for sine and cos. So that's why we got this formula which says theta plus or minus 360 n times. Now here we did, our n was 2 in this case, here n was 1 in this case, here n was 0 because we started from there. You would come back to the same place. Alright, same values. So theta plus minus 360 n, or we can also write it as theta plus minus 2 pi n. 2 pi is 360, right? 2 pi n will give back theta itself. Alright, so we saw that by 2 pi we came back here. So see, this is 2 pi and we started with what? We started with omega t plus phi. So after moving around with 2 pi, we are coming back to same x, that is a sine omega t plus phi. Alright, so what does that mean? The particle reaches the same position after time 2 pi by omega, thus completes one oscillation. Hence the time period t is 2 pi over omega. Alright, we should also not forget that if we take there omega there and t down here, it would be omega is equal to 2 pi over t or 2 pi n. N is frequency. Alright, now moving ahead. So we have proved that time period is 2 pi over omega. Alright, now let's move ahead. Acceleration we know is r omega square. Now since here we are talking in terms of displacement, so it is x omega square or omega square x. So a is equal to omega square x. And this is equal to f over m, which we have seen earlier. F, we don't know, mind you, we are talking in terms of magnitude right now. We already have seen f is equal to kx. So f over m is a kx over m is omega square x. The same thing I wrote it back again here. So kx over m is equal to omega square x. So x gets cancelled. So we get a formula where omega square is equal to k over m. Alright, so this is one thing which you have got to keep in mind always. So k is equal to f over x. K is equal to f over x. Why? Because f is equal to kx, therefore k is equal to f over x. So f over x, so omega square, we repeat again, omega square is equal to k over m, and k is f over x, proved just now, over m. Alright, k is f over x and this m is this m. Alright, so we can say the formula for omega square is force acting per unit displacement upon mass. So if I just put in ma over x and mm gets cancelled, so this becomes a per x. Alright, omega square is equal to acceleration per unit displacement. Now we know omega is 2 pi over t, so it becomes 4 pi square over t square is equal to acceleration per unit displacement. Now if I want to find in terms of time period, t would come here and this thing would go below 4 pi square, and then we also have got to square root both the sides. So t is equal to 2 pi over root of acceleration per unit displacement. This is the formula which has to be kept in mind because used many a times in many numericals. Alright, so this is one formula. Now also we know t is equal to 2 pi root of m over k. Why? Because we already proved omega square is equal to k over m, omega square is equal to k over m. So omega is equal to 2 pi over t the whole square, so k over m. So if we take it in terms of t, then it would be 2 pi root of m over k. Alright, reciprocal of this m over k. Now if we want to find frequency, obviously we would be taking reciprocal of this, that is frequency, which is n. We also use it as f, which is this formula. So these are the formulae which you have got to be well versed with for numericals and oscillation. Okay.